Okay, we're going to try taping this stuff today, and so that it can be posted into your Canvas is where you'll end up finding this stuff at. And so after I get out of here today, I'm going to put this stuff out there for you to take a look at. So 2.5 is more linear equations.
Oh, hell no. What the hell's going on?
You get it worked out over there?
No, it's saying that my code is not working.
Oh.
It's saying that
Well,
something.
you don't need to be on there just yet anyway, so we'll work at it if we get to that point.
Now you're just, hey, you found a way to keep me out there, didn't you?
I did. Isn't that amazing of what I did to do that? In more linear equations, this means that we end up taking the stuff that you learned in section 3.3 and 3.4 and apply it in a little bit different manner, because now what you're going to find is in some of the other ones you did, you only had letters on one side of your equation, or you only had numbers on one side of your equation. And so when you did this part, and you ended up taking this piece and to solve it, you only had that step in there. So with these, I'm going to give you all of the steps that you need to go through. And for step 1, it says to remove all distributions. Do I have anything in there that needs to be distributed in this problem? Yes or no? Is there anything in there that needs to be distributed? No. So I can skip the first step. Step 2 is combine like terms on each side of the equals. Do I have to combine anything with this one?
No.
No, nothing needs to be combined yet. Step 3 is get the variables on one side of the equation. Now, it's important. A lot of you get into solving these things, and when you go through and you solve them, you say, oh, I'm going to get my numbers all together on one side first, and then I'm going to worry about my variables. Later on in Chapter 2, we get into having an inequality sign in the middle here. And when you do that, you want to make sure if you can keep your variables positive when you move them, keep it positive. So you move the variable first and then do your number next. So I've got variables to move. So which is smaller? So I'm going to look at this and move the smaller one to the opposite side. So which one's smaller, 10 or negative 2x? Negative 2x. So that means I'm going to add 2x to both sides. So 10x plus 2x is 12x plus 9. 2x's are gone. Bring down my negative 15. Okay. Step 4, move the numerical values or the constant term to the opposite side of the variable. So I'm going to do the opposite side of where the variable is at. So x is here, so I'm going to move 9 to the opposite side, and I'm going to have 12x is equal to negative 15 and negative 9. What's that come out to be? Negative who? 24. Perfect. And then last of all, solve for the variable by dividing. And so we get that. Whoops, I'm writing off the screen there. So we get all that part done. So now I've got to divide by 12. And I find out that x in this case is equal to a negative 2. Okay. And then last is check. Make sure it works, because again, in Chapter 2, there is no reason to get anything wrong with these. You want to not be working on your homework. You might, if you start paying attention, it might help a lot. Okay. work on that other stuff at a different time. So anyway, put your negative 2 back in here and say 10 times a negative 2 plus 9 equals a negative 2 times a negative 2 minus 15. And see if it works. 10 times a negative 2 is a negative 20. Negative 20 plus 9 is a negative 11. Negative 2 times a negative 2 is a positive 4. And a positive 4 with a negative 15 is a negative 11. Now you might say, "Golly, it takes me forever to check these things." But the amount of time it took me to check this is far greater than the amount, far less than the amount of time it would take if I got it wrong in Hawks. Because if I get this wrong in Hawks, what's going to happen? If I get 3 strikes when I'm doing certification, I'm back doing the whole thing over again. Where if you check it, you'll know that you did something wrong. Okay? Then you can go back up and take a look at it and rework your problem if you need to. Okay? So that's our steps. So let's go through and do some more of these so we get an idea of what we got to do with them. So 5x minus 7 plus 3x equals 4x plus 11 plus 2. So if that's my new problem that I need to do, what would I have to do to it? And you should be taking notes while we're doing these, because then you got some examples to take a look at when you get home.
So first we're going to want to combine them like that.
Yes. So what happens on this side?
So we'll go 5 plus the 3x.
Uh-huh. That gives me 5x plus 3x gives me 8x.
8x.
And what else is still on that side?
Minus the 7.
Perfect. Then go to the second side, and what happens there?
We'll add 11 and 12.
Yep, and get, and 2.
23.
No, 11 plus 2.
Where did 2 come from?
Plus 2. It's always been a 2.
Oh, well, what did I say? 12?
Yeah, no, with a plus in front of it. 11 plus 2 is
13.
perfect. Okay, now what do I do?
So you want to get, let's plus 7 this side.
No, we don't want to do 7. We want to do
13?
no, we want to do the variables. Yes, 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 the variables. So I want a minus 4x from both sides. So 8x minus 4x
4x.
is 4x minus 7. And then do my 13 and bring it down because there's nothing left on this side. Again, those long lines in there, don't forget. So plus 7. And now you're probably saying, wait a minute, I could have put plus 7 over on the other side. And we got the exact same thing because you still would have ended up with 20. But the problem is you want to make sure this variable stays positive. And sometimes if we move the wrong thing over, it makes the variable come out negative. Because if I move the 13 over and I move the 8 over, everything is negative, and I don't want it negative. I want to keep it positive if I can.
Okay,
Okay?
I see why you did it. Okay.
Yep,
So
keep stuff positive.
Wrong, it would have just made it more confusing.
Right, right. Yeah,
Okay,
it just could have caused problems later on if you ended up with a negative variable. So 4x equals 20. So my next step is divide by 4. And so x comes out to be 5. Okay. And then check it. So 5 times 5 minus 7 plus 3 times 5 equals 4 times 5 plus 11 plus 2. Do my sides equal? 5 times 5 is 25 minus 7. 3 times 5 is 15. Again, order of operations from chapter 1. 4 times 5 is 20. Plus 11 plus 2. 25, take away 7. What's that leave me with? 25 minus 7? Good old 18, I think. Plus 15. 18 plus 15 is 33. And does it equal 33 on this side? So 20 plus 11 plus 2 is 12. So 20 plus 12 is, whoops, no, that's a 3. 11 plus 2 is 13. 20 plus 13 does end up giving me 33. And so it does check. Okay. Again, make sure you do those check pieces in there. Let me see if I can find one that has parentheses got to be cleared up. You okay with this one? Questions on it? No? So far so good? Alright. Let's do one that's got distribution to do. 3x plus 2 times x plus 5 is equal to 5 times x minus 1. So this one's got some distribution stuff in there that we need to take care of. So, first step. 3x plus 2 times x is 2x. 2 times 5 is plus 10, right? And same on the other side. 5 times x. And 5 times negative 1. Yep. Good deal. So then, put them together. 3x plus 2x is... And then I get 5x minus 5. And what ends up happening? When I minus 5x and I minus 5x, my x's are long gone, aren't they? Kind of weird how that happened. And I ended up with something that wasn't equal. Okay.
What is that called?
What is that called? Well, that is called a no solution. So in a no solution situation, the variables disappear and the numbers left do not match, so it is a no solution problem. Meaning that there is no value that you can put in for x that's ever going to make this thing work. It will never work. It never has any ability to come out and to work out correctly. Now, what would have happened also as a special thing, what can happen is you have 5x plus 10 is equal to 5x plus 10. When you have this and you go to put your x's together, they all disappear. But in this case, 10 does equal 10. So what happens with this guy? Well, if 10 equals 10, that means that both sides are identical. See how this side and this side are the same? And because they're identical in there, that means that what you have is infinite solutions. X can be anything. So x can be any value that you so choose, and whatever you want to put in it, it can be whatever that happens to be. So you kind of got a variety of things that happen. So you get infinite solutions with that one, and what comes out of it. Now, there are names that go with these. This one is considered to be an identity. So if you've got an identity, that means that it's exactly the same, they match each other, and that's got the infinite solutions. If you have it where they do not match, that is a contradiction. So you got a contradiction taking place there. And the contradiction is, of course, it's not being equal to each other, and so therefore you got it's contradicting itself. So there is no answer, no solution to that. If they work, well, let's find one in here that does end up working out. They give you decimals with some of these as well. So I guess we might as well take a look at one that's got decimals in it. So if you had that one to solve, go through it, work it out, see what you get. See if you can come up with a solution for that one. And work it out and see what happens with it. One of those. 2. First I got to clear out the distribution, so I get a negative x plus 1.3. Combining, there's a 1 in front of there, with that gives me a negative 2.8x plus 6.7. Once I make it to that part, what has to happen?
Plus 1x.
What was it?
Plus 1x.
Plus an x, plus 1x, or do I want to add this thing to this side? Which one's smaller, negative 1 or a negative 2.8?
Negative 2.8.
Right, so I want to add 2.8. And again, you don't see it today of why we have to make sure that's positive, but you will on Wednesday when we get to the last section.
I noticed in the book that
Inequalities.
when they're dealing with decimals, they want to kind of get rid of the numbers.
You can. You can get rid of the decimals in it all together, and I want to show you that after we got this one done. So I want to leave the decimals in it and then show you what's taking them out. So, yep. And so this side I get 6.7 is equal to 1.8x plus 1.3. Subtract 1.3. And that leaves me with 7 take away 3 is 4, 6 take away 1 is 5. And then last of all, divide by 1.8. We're out of room in here. And I find x is equal to, what's 5.4 divided by 1.8? What does that end up equaling? 3. So x equals 3. Now, the Hawks also shows you of getting rid of your decimals. If you get rid of your decimals, what you would do is look at each individual decimal and where the decimal place happens to be. Since all of these are in the tenths position, you could take, after you distribute, because it's easier to get this piece done and then move your decimals, multiply everything by 10. So 10 times 1x is going to be 10x. 10 times 3.8 is going to be 38x. 10 times 6.7 is going to be 67. 10 times the negative x is a negative 10x. 10 times this is going to be a 13. And then you have no decimal points involved. So if you want to, you can remove those. But it still works out basically the exact same way. So 10x from 38 is a negative 28x. Negative 10x plus 13. Move the negative 28 over. And the only thing that does is gets rid of, and then minus 13, gets rid of the fact that you have any decimal points left in it. And now you're working with just plain straight whole numbers, but still x comes out to be 3. So it hasn't changed your values in any way. Okay? And then, what, another one with decimals?
Yeah.
Okay, sure. Yep, we can do another one with decimals. Negative 2.7x minus 2.7 is equal to a negative 2 or 2.1x minus 2.1. Do you want to get rid of decimals or keep them? Get rid of them. So if I get rid of them, notice every decimal is in the tenths position. So that means if I multiply by 10, they'll all go away. 10 times this is a negative 27x. 10 times 2.7 is 27. 10 times negative 2.1 is negative 21. And 10 times that is a minus 21. Okay. Now, guess off rack. So how do I do it? Plus the 21 or plus the 27? I got both of you. Somebody's saying each one. Which one do I want to move?
27.
Because it's smaller. Okay? So add 27x to both sides. That leaves me with a negative 27 is equal to 6x. minus 21. Now what?
Plus
Add 21. Now realize your numerical part can be negative. That's not the one that causes you problems. It's the variable that does. Divide by 6, and I find x is equal to negative 1.
So your x, your numerical part can never, it can be positive or negative, but your variable has to always be positive.
If you try to keep your variable positive, later on we're going to find out why in 2.7, because you end up with inequalities. And every time you get an inequality, if this is negative, I got to remember to switch it. So if I can keep this positive, then I don't have to worry about switching inequalities around.
You just made my life so much easier.
Okay. So that's what happens with that variety. Okay or not okay?
Okay.
Okay. The other kind that you have with these are ones that have fractions in them, and I'm trying to find one that doesn't. Oh, there we go. 3 halves y minus 1/4 equals a negative 5 halves y plus 3/4. Now when you have fractions involved, they're not fun to work with. If you had to move this guy over here, this isn't too bad with that kind of a combination, because if I move this over, it's still halves. You see how that's still a half? And halves match, and my quarters match. So you could do this one by simply adding 5 halves y to both sides. 3 halves plus 5 halves is 8 halves, or 4y. Everybody okay with that? Because I want it down further. Add my 1/4. So that leaves me with 4y is equal to 3/4 plus 1/4. What's that equal to? 3/4 plus a quarter is 4/4 or 1. Divide by 4, and you find y is equal to 1/4. Now when you check this one, I would, instead of putting a quarter in my calculator, what's a quarter equal to as a decimal?
0.25.
Yep. So I'd use 0.25 and check it with its decimal representation. Or we could take that whole problem and come up with its common denominator. What's the common denominator between 2 and 4? 4. And what that would mean is if I take 4/1 and multiply it by each piece in here, what it will do is remove my denominator. So if I multiply 3 halves times 4/1, notice what happens. The 2 and the 4 cancel. 2 times 3 gives me 6y. Quarter and a 4, so 1/4 times 4/1. The 4's cancel, leaves me with 1. You okay with that or not?
Can't you just, like, 2 goes into 4, 2 times 3, 6, right?
Yeah. But if I don't show it, somebody else is going to look at it and say, huh, where'd you get that at? So what Amy's saying is you just take 4 times this part, and 2 goes into 4 twice. 2 times 3 is 3y. 4 goes into 4 once. 1 times the negative 1 is a negative 1. 2 goes into 4 twice. 2 times the negative 5 is a negative 10y. That's what you're talking about, right?
Yeah.
And 4 goes into 4 once. 1 times 3 is 3. And what that does for me is it gets rid of all those fractions. I don't have to think about them anymore. So then add 10y to both sides. Gives me 16y minus 1 equals 3. Add 1. Gives me 16y is equal to 4. Divide by 16, and I find that y is still equal to the 1/4 I had before. So you can get rid of them. I kind of like getting rid of them because, especially when you don't have matches right here. Let's say if this would have been a 3. When I pull a 3 over there, I got to find common denominators. So if I can go through and clean them out, and then you don't have them in there. All right? Yes or no? So far, so good? Okay. So that's kind of the main pieces with those. Then if you take a look at your story problem section that I gave you, and I gotta find my oversized pieces here. They do give you a couple different types of story problems in this section. The two that they give you are a trapezoid question and a English written out section or statement that you can end up making into a value. Let me get my stuff out of here. Okay, so if we look at the trapezoid, my paper's stuffed together here.
On this one?
Yeah, your handout I gave you, and you got all of you got a sheet, I think, at the beginning. What happens with this is that if you've got this trapezoid one, for instance, what is the area of a trapezoid? What's the formula for that? Anybody know what the area formula happens to be for a trapezoid?
Half times base times height.
Half
Or
height. 1/2 the height times big B plus little b. If you look at a small base and a big base, that's going to end up equaling my area of a trapezoid. Y'all okay with that part?
Yep.
Okay. So now what my story problem starts telling me, it says the area of a trapezoid is 250 centimeters squared. So where is that in my formula? So I'm going to start plugging stuff in. Well, that's area. So 250 is my area. The height is 20 centimeters. So that means I have 1/2 times 20. You all agree so far? Okay. And the length of the parallel side is 10 centimeters. Now, parallel side. So I guess we need to look at maybe what a trapezoid looks like. Trapezoid looks like so. The height is what's dropped in here. And the bases are these two parallel pieces in my trapezoid. So my little base is here, my big base is there. And so where does this 10 go? Well, the 10 goes inside my problem. It says find the length of the second parallel side. So if I know this side is 10, I need to find that big side, right? If we find the big side, it's got to just be a b or a variable that happens to fit in there. We okay with that part? Everybody got that? Of what happened to that one? Okay. So, what comes out of this? Well, I have 250 on this side. What's 1/2 times 20? 10. Okay. So, if I finish this, I got a distribution. So I have 250 is equal to 10 times 10 is 100 plus 10b. So I got to get b by itself. So how do I do that? Minus 100. And that leaves me with 150 is equal to 10b. Divide by 10. And I find big B is equal to 15. Does it work? Did it check? Does it check? So plug it back in. 15. Oh, I gotta go over here. I can't do that up there. I keep forgetting I can't walk when I'm taping stuff. Okay, so I plug 15 in here, plus 10, and 1/2 times 20 had better equal 250 when I'm all done. So 15 plus 10 is 25. 2 and the 10 and the 20 cancel, so I have 10 times 25, or sure enough, it worked. I got 250 out of it. Okay. Are we all right with trapezoids? What do you think?
Yes.
Okay. The other one that they put in there is this one. And it's just written out, and so we need to interpret it and put it into an equation. This goes back to, what was it? Section 2.2, I think, is the one that had all the written words we had to write out. So let's read it as it is. It's 6.8 plus, what's plus mean? 9.3 times a number. What's a number mean? X. Equals, of course, means equals. the sum, so what's sum going to tell us what we got to do? Sum means I need to add, right? Yeah. Of the number and 11.3, what is the number?
N.
Okay, so we're going to put n in there? All right. So 6.8 plus 9.3 times the number, so n, we're going to use, equals the sum of the number plus 11.3. Okay, so that's what it means written out into algebraic statement. So what happens with this? So what do I end up with? 6.8 plus 9.3n is equal to n plus 11.3. Okay. Move who?
The N, one N.
So minus an n. So that leaves me with 6.8 plus 8.3n is equal to 11.3. Now what? Yep, minus 6.8. And what happens after that? Gotta subtract these two.
4.5.
Okay. Divide by 8.3. And what is good old n gonna be?
Ooh, not good. 45 83rd. Did I say that right? Did I get that right?
45 over 83. Yeah, if you removed your decimals, it would be. What would it be as a decimal? And sometimes they'll tell you to round to a certain spot.
5, 4, 2, 1.
Round to the nearest thousandths with this one. 0.5.
4, 2.
2. Okay. So that would be what n happens to be. Not a pretty number. Okay? Because it goes on indefinitely. But you got the idea? Pardon?
The numbers, I always think I got it wrong.
What one?
When I see numbers like that,
You think you have it wrong?
I have it wrong.
Usually what gives you a clue that you're on the right track is in Hawks it'll say something like round your, if your answer is not exact, round it to the nearest thousandth. Usually if they put that statement in there, round to the nearest thousandth, that tells you you're on the right track. Okay? Yep. Number 3 is the trapezoid, but I think we're okay with that one, aren't we? We okay with that one?
Let's do one more.
One more? Okay. We know our area of a trapezoid is A equals 1/2 the height times big B plus little b. Correct? So, if that's our piece that we have, so what do we got to plug in? Well, 175 goes in for A. What's my height? That says the height is 14. The length of a parallel side is 6, so 6 plus big B, right up here. Height is 14.
Oh, it says right there.
Says it right smack dab in front of you. It'd reach out and slap you if it could, you know?
It probably would.
Okay, so solve away. So 175, 2 and goes into 14, 7, leaves me with 6 plus big B. Distribute. 6 times 7, good old 42. 7 times B is 7 big B. Now what?
Oh, hold on. Get here. So you would minus 7B. Wait, no, you won't. Yeah, minus the 40.
Perfect. Yep, minus 42. So 175 minus 42 is 133. So 133 equals 7b, divide by 7. And so what's big B equal to? 17? 19? Okay. 19.
Bam, I'm in there.
All right, and then you would check it, of course, and plug it back in. All right, yes or no? We good? Good. Okay. Then, let's set this one up. If 4.5 plus 6.7 times a number equals the sum of the number and 29.8, what is the number? So this is just like the other one we did. So it's going to be 4.5 plus 6.7n is equal to n plus 29.8, and then you would solve it from there. Okay. Again, I think you can solve it, correct? You guys solve that one? Okay. So you can end up getting what your answer would be for that one. And the answer for this one ends up being, I don't know, what did we end up with for an answer? I guess 4.44, you said?
I got a fraction.
Yeah, I got the same question.
4.44? Okay. So we get 4.44 for that one. Okay. Good deal. So that is all of 2.5 that we happen to have. Okay. Now, so that is all of 2.5. Moving on to 2.6.
Yeah, this is the one, woo, yeah.
And 2.6 has applications in it.
I'm even going to pause my stuff.
2.6a, 3 parts to 2.6. We might not get through all of them. We might get through 2.6a and 2.6b, and then we'll hold off on 2.6, the other one, for the next time when we get together. Okay. So in 2.6a, we need to, of course, read the problem to understand it. So basically just go through and read it once, then go back and read it a second time to see if you can come up with a answer for it. Second is devise a plan. Assign a variable for what you don't know, or for the missing piece. Step 3 is solve it. And finally, step 4 is to do a check. Now within these, there are some different varieties and different things that come up. One area that they talk about is consecutive numbers. What in the world do we mean by consecutive numbers? Anybody give me an example of 3 consecutive numbers? 28, 29, and 30. So what could we say about those? They are basically numbers that are in order, or, yep, one after another. So we've kind of got that combination in there. So what happens if I don't know my consecutive numbers? Because we could go on all day writing consecutive numbers up here, correct? So if I don't know what the first one is, if the first one's x, how do I find my second one?
X plus 1.
Because if you follow these up here, if you've got 28 for your first number, how did I get to 29? I get to 29 because it is x plus 1, correct? Okay. How do I get to 30?
X plus 2.
Right, x plus 2. How would I get to a fourth one?
X plus 3.
X plus 3,
Yeah,
okay?
right.
All right. So we okay with that part of coming up with these? Because what you are going to have to come up with in these algebra problems is the unknowns, okay? So if you don't know the first one, the second consecutive is plus 1. The third is plus 2. The fourth is plus 3, okay? So you keep working your way up with those. Then they also give you consecutive odd numbers. So that's in numbers in order, but are odd numbers. So give me 3 consecutive odd numbers. 35, 37, and 39 would be 3 consecutive odd numbers. You okay with that part? So another consecutive odd numbers might be 47, 49, 51. Okay? Now how do I get there? If I have no clue what the first one is, how do I get the next one?
It will be x plus 1. No, 2.
X plus 2, because 35 is my first one. 35 plus 2 gives me 37. We okay?
Yep, and then the next will be x plus 4.
Mm-hmm. Yeah, because 35 plus 4 gives me 39. Okay? So if you're ever stumped with consecutive numbers, just write out some. Just give yourself an example of some, because if you give yourself some examples, then you can say, I don't know what the first one is, how do I get to the second one? I don't know what the third one is, how do I get to it? From this number, how did I get there? How did I take 35 and turn it to 39 and get my other answer? Then the last one is consecutive even numbers. So what about those? So they're still numbers in order, but are even numbers. So what's an example of some even numbers? Give me 3 of those.
4, 6.
22, 24, 26, and what did you have? Oh, still works the same? Okay. So how do I get these guys? If the first one is x, how do I get the second one?
X plus 2.
How do I get the third one?
4.
But wait a minute. My odd ones is the same pattern. How can that be?
It doesn't really go off of.
You just add the numbers as you count from your consecutive measures.
Okay, you kind of add stuff, but it's basically where you start with. If you're starting with an odd number here, by adding 2 it still stays odd. By adding 4 it still stays odd. Down here, if I start out even, by adding 2 it stays even. By adding 4 it stays even. So your patterns there are the same. Okay? So, you ready to try some of these guys?
Yeah.
Let's see what we can do with these story problems though that we have in this
We're gonna go
section.
to the,
We are going to the story problem sheets. Yep.
Alright.
2.6a. If we look at the very first one up here,
Oh,
8
8
times a number, so 8n, right?
minus 6.
Decrease by 6 equals Is it over 2 plus 9, or is it just over 2?
No, 2 plus 9. It says divided by 2 plus 9.
Divided by 2 plus 9.
Actually, I didn't do mine like that.
See, I put mine over 2 plus 9. Is that going to give me a wrong answer?
Wait, see.
It will give you a wrong answer.
Now, how do you...
Or this plus 9 has to be added in afterwards.
Oh, okay, this is where I get mixed it up. Okay.
So when it says divided by 2 plus 9, why isn't it 2 plus 9? Because I'm sure probably in Hawks there's probably a comma right there. That means you stop.
Okay, so
And then you add your plus 9. So be careful with commas. I'm pretty sure there's a comma in there. I didn't have a comma in mine. I need to add that in. So I'll have to go back and fix that. Okay. So how do I solve this?
Alright, so.
I got this denominator thing in here. So I probably want to get rid of it first.
Yeah.
So multiply everybody by 2. 2 times 8n is 16n. 2 times 6 is 12.
Multiply? Yeah, because you want 2.
You want to clear your denominator out.
Oh.
Okay?
2n?
Yeah.
2 times n over 2. The 2's cancel. Leaves me with n.
10.
And 2 times 9
18.
is 18. Whoops. 18. Okay.
Okay,
Get my n's together. Minus n.
So,
So that gives me 15n minus 12 is equal to 18
plus 12.
plus 12. So now I have 15n is equal to 30. divide by 15, and I find n is equal to 2. And that's my answer.
2.
So n equals 2. We okay?
Bam. Got it.
Good deal. Yes or no?
Alright, I know I'm
You didn't get that?
Well, I got the same answer, but I did it different.
What'd you do?
I just wrote it out and then I added 6 to both sides and then I multiplied everything by 2.
Yeah, your same thing. You're just saying you're getting this piece over here first,
Oh.
and then you're just multiplying by 2. You just have one less number in there.
Oh.
Yeah, you're fine. Okay.
Oh,
Yes or
man.
no?
I'm confused on the next one.
Okay, let's look at the next one.
When it says more than the number, like I know that it's 28, but
What's more than mean?
add,
Yes?
so plus, what
Yep.
n?
Yeah, I got an extra T in there that I don't need. Okay.
I'm good to go now.
4 times a number plus 16. So what does that mean? 4n plus 16 equals
28.
more than a number. How does that go? Does it go 28 plus n, or is it n plus 28?
N plus 28.
Okay. And you can solve it from there, correct?
Correct.
Yeah.
You guys good after that? Okay.
N equals 4.
Number 3 is find 2 consecutive integers whose sum is negative 139.
So they have to be one right
Wait a minute.
Ooh, we got.
I don't get that one.
Okay, well, we're going to talk about it because it's got this 2 consecutive integers, meaning numbers, basically, is integers, because we're getting into negative and positive numbers here. But 2 consecutive integers. So what does that mean? What do I know about these consecutive integers? Do I know anything about them?
They're one
Yeah.
right after another.
So it'd be like,
Yeah. So that's kind of like going back to my notes here. If we go back to the note page, the note page said if I got consecutive numbers, remember that 28, 29, and 30, we said if I didn't know what the first one was, it's x. If I don't know what the second one is, it's x plus 1. Remember that? Okay. So that's what I got to do here
but
because I don't know what the first number is,
so
and I don't know what the other second one is, but I know find the 2 consecutive integers whose sum. Sum means I need to do what to them?
minus the 2 other integers.
No. What do I do to them?
Oh,
I
wait.
got to add them.
3.
X plus 1, because this is the first integer plus the second integer, is equal to a negative 39. I think what's thrown you is that negative on that 139.
No.
X
it had
plus
nothing to do
X?
with that.
Didn't have anything to do with it? Okay.
It had to do with 2 consecutive integers whose sum was.
Yep. But if you got consecutive integers and you don't know anything about them, they got to be added. So x plus x is 2x plus 1
Plus 1
equals a negative 139. So take 1 away from each side.
1 negative 40.
Get negative 140. Divide by 2. So x is going to equal a negative 70. So what's my 2 numbers?
So it'd be negative 70.
And
The first one.
Negative 69.
so the second number, this is the first. The second, remember, was x plus 1. So a negative 70 plus 1 is a negative 69.
Wait, what did you get for, can you hold that paper down a little bit more so? Yeah.
Supposed to be x.
Wait, how did you figure out?
Could I put
the
x1,
two?
x2?
How did I figure out the second one? Is what you're asking?
Yeah.
Okay, when I solved this one, I got x equals a negative 70, correct?
Oh, yeah.
So that's the first. The second consecutive number is x plus 1.
Gotcha.
So then I got to go over here and plug and replace x with a negative 70.
Gotcha.
Negative 70 plus 1 is a negative 69. And that's how. And then the check is a negative 70 plus a negative 69 equals a negative 139. And it does check. Okay? All right, next one. What happens with that one? See if you can work it out.
Okay, here, yeah, let me see.
2 consecutive integers. We got those guys back again. So we know the first number is x, the second is x plus 1, because they're consecutive integers whose sum is 87 this time. Questions?
Bam, I think I got
Are we
it.
doing okay or not okay?
I think so.
Okay. Subtract 1. Leaves me with 2x is equal to 86. Divide by 2. And I find x is equal to 43.
Plus 1.
So the first is 43. The second is x plus 1, or 43 plus 1, or 44. And the check, if 43 plus 44 does equal 87, and the last time I added them together. Okay? Yes or no? We good?
Good, yes.
We're good? Okay. And I think there's another one that's in there of odd ones.
Ooh, wow.
Find 3 consecutive integers. You should be okay with that one, right? All it means is you've got 3, you have x, x plus 1, and x plus 2.
Can you do one of them, please, if you don't mind?
What?
Sorry.
We'll go through that one?
Yes.
Okay.
Yeah.
Yep. Because that one is a kind of a complicated one, so we'll go through it. If 3 consecutive integers such that 3 times the second, so what's my second integer? X plus 1 is my second. This is my first, second,
3 consecutive terms.
third,
3 times the second
is,
more than the sum of the
is means equals. Beware of that. The is means equals. 10 more than the sum of the first and the third. So sum of the first, which is x, plus the third, which is x plus 2. We okay so far? But it is 10 more than that, so that means I need to add in 10. And that's your equation that you have.
Oh, wow. I just go to
Are
that.
they going to use one of these on the test? That is just
I don't think there's one that's that difficult on the test.
okay.
No. In your homework there will be. In your certify it will pop up. But I don't think it's on the test to be that difficult. And then you'd solve it. So I'd get 3x plus 3 equals x plus x is 2x, and 2 plus 10 is 12. Get my x's together. Minus my 3. So the first number is 9. First number is 9. Second number is 10. And the final number is 11.
Oh, wait, hold on. I got x equal to 9.
Yes? X equals 9. That's
Okay.
the first number. First number is x.
Okay.
My second number is 9 plus 1, or 10. The third number is 9 plus 2, or 11. So that's my 3 numbers.
All right, gotcha.
Okay. Let's skip number 6, because number 6, excuse me, is one of those ones that you read. And let's go to 7. The sum of 2 consecutive odd integers. So if I got odd integers, what are those going to be?
The x
Plus 3.
plus 1.
An x plus,
3.
no, x plus
1.
2.
Oh, yeah.
Remember again, if you don't know that, just put 2 odd ones up here, 3 and 5. How do I get from 3 to 5?
Plus
3,
2.
and I get a plus 2. Yep. So sum, what does sum mean?
So,
Add.
plus sum of
Is 120. So it equals 120. So 2x plus 2 equals 120. Minus 2.
minus 2
So 2x equals,
118.
divide by 2. So x equals 59. So what's the two integers? 59 and
57, no.
61.
I don't know what the hell I'm doing.
x plus 2, so 59 plus 2 is 61. Yes or no?
Hold on.
Good guess.
1.
Are we all right? Okay.
They only wanted 2. Hold on.
I've got something missing on number 8. I got to fix number 8 because 8 doesn't have what it needs in there, and I think that was all of them that we had from that part. Okay. You are. So are we A-okay with these guys, you think?
Yeah.
Okay. 2.6b.
Yeah, this is where it kind of got tricky.
2.6b gets into looking at general straight story problems that involves all kinds of stuff with these. So let's see if we can go through and set some of this stuff up and see what happens with these. Now, they are, again, regular straight story problems, so we got to read them carefully and see what we get out of them. So if I read this thing, it says, a t-shirt costs a total of $7.95. When it says total, what does that mean? Total means
Full price.
full price, nothing else added into it. But then it goes on and it says including a 40-cent sales tax. What was the actual price of the t-shirt? Do I know what the actual price of the t-shirt happens to be? So the actual price is X, correct? Because I don't know what it is.
Yep.
So total means I need to add the t-shirt's price plus the sales tax, right? Because we do these things all the time. We go out shopping. So X plus 0.40 cents is equal to 7.95. So what is the value of my t-shirt? So I'm going to minus the 40 cents. And I find out that X is equal to $7.55. So that's what my t-shirt costs. We okay with that one? That one's kind of a pretty simple one.
See, it's not even once you get it set up, it's fine getting set up.
Always with story problems, it's the setup that's the problem. But if we go back and interpret what we just did, total made me think addition. I got to add something together to get a total, because that's the only way I can get totals. And it was this, but including this sales tax, what was the actual price? So I didn't know what the price was, so that's why I had to have the actual price be X. Okay? Assign your variables. Before you start writing anything out, make sure you know what that variable is going to be. So if we go to the next one. The original price of a calculator was reduced by $12.95. What does that mean, reduced? Reduced means what in? Yeah. Means subtraction. Yeah, means to subtract. So you got to subtract some stuff there. The sales price was $77.10. What was the original price? So we don't know the original price.
So X minus
Original, like we use original price like O or X.
We'll use X. Don't stay away from O's because they look like zeros when you're doing your math. So we don't want to end up doing that part with it. We're going to make it X. So how does this set up?
X minus 12.95 equals 77.10.
Okay. Are we okay with that one?
Yes.
So then all we do is we add $12.95 to each side, and I find that X is equal to 90.05 cents, right? $90.05. Okay. I know, because when you look at it, you say, I just got to subtract. Well, wait a minute, but I can't just subtract it from this, so be real careful. Yep. So You did. You did exactly that, but you're solving for your variable. Yep. Didn't know you were solving for a variable when you did that. All right, the next one. The sum means what? What's sum meaning? Sum means we got some addition going on there, right? Of all measures of all angles in a triangle is 180 degrees. So the sum of all those separate measurements of the angles in a triangle is 180 degrees. If the measure of two of the angles is 66 and 25 degrees, what's the measure of the third angle? Now you're probably looking at this one and saying, Kyle, all I got to do is take 180 and subtract 66, subtract 25, doggone, I got it, right?
Yep.
Okay, but they want it in algebra, so we need to know the other angle is x, so x plus 66 plus 25 is all equal to 180. So again, you got to set it up and get it into those.
I could figure it out in my head, but I couldn't put it to an equation.
Yep, but that's the piece that we need to do with that one. Okay, so x 66 plus 25 is 91. Subtract 91 from all sides, and I find out x is equal to 89 degrees. Okay, not bad, right? So far, so good? Okay, now the next one. Sam spent $276.57 on a new camera that was after a discount of $53.23. What was the original price of the camera? I think you can do that one too, right? You guys okay with that one? Okay.
Hold on, let me know I'm not ready.
All right, let's write it out
I
then.
mean, even if we just went through and set them up, so I make sure, because when it comes down to those,
Okay.
I put either more into it than I need to, or I ain't putting enough. Something's
Okay.
not.
So what do we got to know in here? We now know the original price of the camera. So the camera price. Do I know it? That's X, correct?
Yeah.
We know he spent $276.57, but that was after a discount. So what does a discount mean?
So the X
Minus. So X minus 53.23 equals 276.57. Right. That's what he would walk out the door with. Okay? Now, be careful in Hawks, because a lot of the questions are two-parters when you get to this section. The two-parters come in by the basis that they're going to say, what is the equation? So what's the equation? So you need an equation in there. You don't just hop to the answer. So read carefully when you're doing those. So this is the equation, and so then you'd subtract the 53.23, or add the 53.23, and then you'll get your what x happened to be. But be careful, because it's going to ask you for the equation. That's the equation part. And then, so my answer on this one is what? What do you guys get? $329.80. Okay. Yep. Okay. One other one that fits into that category. The travel time, 42 minutes, from my street to the park, less the time to reach the bus stop, is 18 minutes. How long does it take me to reach the bus stop? Youch.
18 minutes.
So
I don't know, shoot.
So
Hold on.
42 equals.
So,
From my street to the park, less the time to reach the bus stop is 18 minutes. So what's the 18 minutes?
so that would be like X minus, I don't know.
I hate starting from.
42 minus 18 equals X.
Okay, we've got a stab in the dark. 42 minus 18 equals X.
Yeah,
Sound good?
oh, I didn't get that.
I don't know if I'm correct, so don't hold anything against me.
Travel time, 42 minutes. 42 minutes is the full amount of time it takes you to travel from your street
To the park. So wouldn't that be 42
to the park.
equals?
Okay. Less the time to reach the bus stop, so which is 18 minutes. So what do we have going on here?
I don't know, I think it's mixed up.
I think it's mixed up. This is the total.
Is the total, so 42 equals.
This is a part.
So we know that.
So what do we got to do? We've got to walk from your street to the park. How long does that take me?
X minutes.
Okay. And then to reach the bus stop, less the time to reach the bus stop. So if I walk another 18 minutes,
So
right,
yeah, X
I'm going to take out my whole time of travel,
plus X.
which is 42. Okay?
All right.
So you're kind of on the right track when you said the 18 in there, but you're not really on the right track because you got to be careful with what you got. You didn't get an equation. If you type this in as your equation to Hawks, it'll say, no, not quite right, okay? This is your equation that has to go into Hawks. So what's my answer?
44.
So X equals 24 minutes.
Now, could I have figured the right answer out with my equation?
Yeah, because 42 minus 18 is still 24. So you still would have had it. Okay? Yep, you still would have had it if you worked it out that way. Okay.
1.6
No,
are we?
no, because you're going to give you some time to work on these, so then I can wander around and help you with them.
All
Okay?
right, good, good, good. I think I might
So we are.